Okay, let's unpack this. We just think about how much of our lives really happen on social media now. It's amazing for connecting, right? Sharing stuff.
Absolutely. The scale is just unprecedented.
But with that scale and speed, it brings these huge challenges, especially, around security, keeping up with how people use these platforms.
Yeah,
It changes so fast.
it really does. The landscape is just constantly shifting, and the sheer amount of data, well, it makes the old ways of monitoring pretty tricky.
Exactly. And that brings us to what we're diving into today. We've got some really fascinating research here looking at exactly this problem. How can we actually get better at spotting something incredibly difficult, like potential terrorist activity online?
Yeah, this is cutting-edge stuff.
It's based on a paper from Sorbonne University, just out April 2025. The author is Noor El-Huda Ben Shabani, and the title is Terrorist Group Detection Framework.
And it proposes a genuinely new way of looking at things, moving beyond what's been tried before.
Right. So our mission here is to really get into this research. What's the problem they're tackling specifically? What's their sort of unique solution? And crucially, does it actually work? What did the results show?
And the paper mentions, importantly, that these groups are not only using social media more, but they're also getting much more cautious about how they do it.
So it's not obvious stuff. Okay.
Yeah.
So the researchers looked at existing methods, ran their own tests. We're going to walk you through what makes this new framework different and why the findings could be pretty significant for, well, for all of us online.
Okay, so first off, the researchers really emphasize how central social media has become. They actually cite some analysis from Evan Coleman.
Oh, yeah. What does it say?
It states that, quote, today, 90% of terrorist activity on the internet takes place using social networking tools.
90%. Wow. Okay, that single stat really tells you how much the ground has shifted, doesn't it?
Yeah.
So let's get into the challenge then. Why is it so incredibly hard to detect this kind of activity on platforms that are, designed for open connection?
Well, there are a few big reasons. Social media offers a kind of virtual firewall, a degree of anonymity anyway. It buffers identities.
Right, you're not always who you say you are.
Exactly. Plus, it allows for direct contact, sometimes encrypted, which makes things like recruitment, planning, spreading propaganda much harder to track than maybe, say, old school forums were.
And the paper really stresses that their online behavior is getting more unpredictable, more cautious. They're adapting all the time, not using simple keywords anymore.
Precisely. And that's why, as the researchers point out, a lot of the existing detection methods just aren't quite cutting it.
Like what? What are the limitations?
Well, for starters, trying to monitor manually, it's just too slow. Needs massive resources. It doesn't scale at all.
Impossible with billions of users.
Right. Simple firewalls. Easily bypassed. And a lot of the academic attempts before, they often focused too narrowly. Some only looked at user activity like the content of posts, who like what.
Okay, the what?
Yeah, but they struggled to capture the dynamic change, the how and when people change their behavior. Others focused only on the network structure like who's friends with whom.
The who?
But then they missed the actual content, the actions. Plus, most were stuck looking at just one social network at a time or only one type of data.
And then you've got that extra layer of complexity, which is huge now, platforms being linked, like your Facebook is connected to your Instagram, maybe other things too.
Exactly. People have these multiple connected digital identities. They don't exist in neat little silos.
So if you're only looking at, say, Twitter, you're missing a huge chunk of the picture about that person's overall online life.
You're in some crucial context. Absolutely.
Okay, so we get the scale of the problem, the limitations of what's been done before. Now, let's get to the exciting part. The solution proposed in this research. What's the fundamental idea? What makes it different?
The core concept really is that it's a hybrid solution. It doesn't make you choose between looking at the static structure, the relationships, the groups, and the dynamic behavior, what people are actually doing.
It does both.
It integrates both simultaneously. They argue you need to see not just who someone's connected to, but also what they're actually saying, doing, sharing, and when.
Okay, that makes intuitive sense.
But the real innovation, I think, is how they model the online world. They don't treat Facebook, Instagram, Twitter as separate islands. Instead, they use something called multidimensional networks.
Multidimensional networks. Okay, what does that mean in practice?
Think of it like this. A single user exists across multiple social networks, right? This framework represents that users' presence on Facebook, Instagram, Twitter, whatever platforms you include, as different dimensions or layers within one single unified network structure.
Ah, okay. So it's like picturing a person being active in multiple rooms, the Facebook room, the Instagram room, the Twitter room, but seeing it all as one interconnected building.
That's a really good analogy, yeah. And the researchers argue this has big advantages. You minimize information loss because you keep the full context. It can actually reduce analysis time by giving this unified view. And you just gather richer information on that same user across all their platforms.
Interesting. And it's not just the structure across these dimensions, right?
Right.
They also pull in different kinds of data. You mentioned that earlier.
Correct. That's the other key piece. It's a multimodal approach. They analyze 3 distinct types of data from these networks all at the same time.
Okay. What are the 3 types?
So first, there's textual content data. This is the obvious stuff, like posts, comments, captions, even text hidden inside images sometimes.
Right.
Second, image content data, the actual photos, profile pictures, shared images, visuals.
Makes sense.
And third, general information data. This is more the profile stuff, age, gender, listed relationship status, but also things like how long their username is. Does it have unique characters, number of friends, average posts per day, follower counts, that kind of metadata.
Got it. So the real power here is combining all of that. The hybrid structure and behavior analysis across multiple network dimensions and pulling in text, images, and this general info data all together.
That integration is exactly what they highlight. It lets the framework handle complexity that, more narrowly focused methods tend to miss, which naturally leads to the question, how does it actually work? How do they put it all together?
Yeah, let's walk through that. What are the steps involved in their methodology?
Okay. Step 1 is building the multidimensional network. So they collect the data from the different social networks. In their tests, it was Facebook, Instagram, and Twitter. And then they structure all that data as this complex graph. Remember, each social network is a dimension or a layer. Users are the nodes existing across these layers. And the connections between users' friendships, follows, maybe shared content, those are the edges in the graph.
Okay, so you build this complex, layered map of users and connections. Then step 2 is detecting anomalies, finding the unusual patterns within that map.
Exactly. How do they spot users who look structurally out of place? This involves a few phases. First, community detection. The system automatically finds natural clusters or groups of users based on how they're connected in this multidimensional structure.
Okay, finding the neighborhoods in the network.
Kind of, yeah. Then phase 2 is anomaly score estimation. For each user, it calculates a score based on how much their connections and position deviate from the typical patterns within their specific community or neighborhood. It also considers their influence, how central they are in that group.
So how weird are they compared to their friends, basically?
In a structural sense, yes. And then phase 3 is score classification. They use a statistical model the paper mentions using a beta distribution, which is good for scores between 0 and 1 to analyze these anomaly scores. It helps categorize them and flag users who are statistically significant outliers within their community.
Okay, so that flags users based on the network structure, but that's just one piece. Step 3 happens alongside this, right? Analyzing the multimodal data.
Right. In parallel, this is where the text, images, and general info come in. Each type gets analyzed by a specialized machine learning model.
Okay, what do they use?
For text analysis, they use something called KGBERT. It's a type of language model that's apparently quite good at understanding relationships in text, and, importantly, it can work well even without needing lots of external information during its training phase.
Okay. And for images?
For image analysis, they used a CNN, a convolutional neural network. That's pretty standard for image processing, but they used a couple of tricks to boost performance. Transfer learning, basically starting with a model that's already been trained on tons of general images, which speeds things up, and data augmentation, creating slightly modified versions of their training images, like rotating or brightening them to make the model more robust and accurate. The paper actually notes that using both together gave them the best results for images.
Smart. And the last data type, the general info.
Right, the general information analysis.
Mm-hmm.
For this, they used standard classification models. First, they had to encode the non-numerical data like male, female, or single in relationship into numbers the models could understand.
Standard procedure for that kind of data.
Yeah. They tested a few different models and found that SVM, which stands for Support Vector Machine, worked best for classifying users based on this general profile information.
Okay, so now you've got potential anomalies flagged from the network structure, plus scores coming from the text analysis, the image analysis, and the general info analysis. Step 4 must be putting it all together, the decision-making part.
Exactly. This component fuses all those signals. It takes the scores from the three data analysis streams: text, image, general info. Interestingly, the researchers found that the text and image content scores were generally more predictive, more reliable indicators.
Then the general info.
Yeah, the general info could sometimes be noisy or maybe even misleading on its own. So they applied weights to the scores. They gave more importance, more weight to the text and image results when calculating the final score.
So not all evidence is treated equally. Makes sense. Like weighing eyewitness testimony differently based on reliability.
That's a great analogy. Based on these weighted scores, the framework calculates a total terrorism score for each user. This score reflects the combined signals across all the social networks, all the dimensions they analyzed for that user.
And then, how does it decide yes or no?
Finally, it uses an automatic threshold. Think of it as a cutoff point. If a user's total score reaches or goes above this threshold, the system flags them as potentially exhibiting terrorist behavior.
Yeah, and they set this threshold.
In their experiments, they found a value of 0.63 worked well as the cutoff. But the key is that it's automatic. The idea is the system could potentially adjust this threshold itself over time as it sees new data, making it more adaptive.
Okay, right. Problem, solution, methodology. It's complex, but logical. Now, the crucial part, the results. You said it was oppressive. How well did this framework actually perform when they tested it?
This is where it gets really interesting. Using their test data, collected from real Facebook, Instagram, and Twitter profiles, the framework achieved an overall accuracy of about 95%.
95% accuracy. In detecting this kind of hidden behavior online, that sounds incredibly high.
It is, especially in such a challenging domain. And they broke down the performance against the specific challenges they wanted to tackle.
All right, like the different data types, the multiple networks, how did it do there?
It showed real strength across the board. For a multimodality of data analyzing the different types, the precision was very high. Almost 98.8% for text analysis, over 94.6% for images, and nearly 91.9% for the general info.
So when it flagged something based on text, for instance, it was almost always correct.
Highly likely, yes. That's what precision tells us. Then, for multidimensionality of networks handling users across different platforms, it hit that 95.144% accuracy. And the paper specifically notes this stacks up really well against other methods they reviewed that also used multidimensional networks but got lower scores, like one cited around 89.5%.
So handling the cross-platform nature really helped. What about the other parts?
For community detection, finding those groups within the network structure, they reported over 96.1% precision, again, outperforming a previous benchmark method they mentioned, which was around 91.1%.
Very.
And finally, for assessing the dynamicity of behavior, capturing how users act and change over time, the framework achieved over 92.3% accuracy, which was better than other methods cited, typically hovering around 88%.
Wow. So it wasn't just one piece carrying the weight. The success really seems to come from the integration of all these different parts: structure, behavior, multiple data types, multiple networks.
That definitely seems to be the core finding. The framework works well because it mirrors the complexity of the actual online environment it's trying to analyze.
So let's bring this back to you, the listener, and the bigger picture of online safety security. What does a potential breakthrough like this actually mean?
Well, achieving accuracy near 95%, that's a potentially significant leap forward. It suggests a much more powerful way to sift through the enormous amount of online data to find these very specific hidden signals.
Yeah, you can see how this could have real implications for intelligence agencies maybe, or security researchers trying to understand these evolving threats. And even for the social media platforms themselves, it offers a potentially much more sophisticated tool.
A tool to identify and maybe mitigate risks more effectively than perhaps current methods allow.
What seems really powerful about it, from our discussion, is how it embraces that messy reality of online life. Identity spread across platforms, communication being text and images and connections.
Exactly. It looks at the user holistically across their different online footprints. It acknowledges that complexity rather than trying to simplify it too much. That integration seems to be the key.
And it's a great example of how these advanced techniques, we mentioned KGBERT, CNNs, SVMs, network analysis, when applied thoughtfully to real complex data, can actually offer new ways to tackle really critical security issues.
Absolutely. And looking ahead, the paper does give a hint about where the author wants to take this research next.
Oh yeah, what's the future work?
They mention extending the analysis, possibly incorporating other types of structured data, maybe linking different knowledge graphs, these big networks of information about entities and relationships.
Okay, going even deeper into connections.
And also trying to discover common semantic patterns between different social network graphs, which sounds like trying to understand the underlying meaning or intent behind interactions at a much deeper level, not just analyzing the surface words or images.
Fascinating.
Hmm,
Suggests there's even more potential for understanding these complex online behaviors down the road.
it certainly does.
Which, I suppose, leaves us with a final thought for you to consider. Given how interconnected, how complex our online lives are becoming, how do you think this ongoing race, this technological arms race, between increasingly sophisticated detection methods like the one we discussed, and the constant evolution of online behavior trying to evade detection, how will that continue to shape the digital world we all live in?